All right. Hello, hello. Welcome, everybody, to the Trino virtual meetup in the Americas. Today, we're going to be joined by our guest, Aaron Colcord, and he will be talking to us about how to build a lake house simply. And so I like the title. It was a very simple title for a very actually powerful concept. So we've talked about lake houses before when we've had folks like the tabular folks for Iceberg, as well as some of the Databricks folks on Delta Lake, and more recently some of the folks around Hootie. And so I remember it was really kind of a confusing term for me at first when I heard lake house, because I'm like, well, how is this different from a data lake? And so essentially, I mean, in my mind, kind of lakehouse boils down to getting a lot of the things that we came to expect around data warehousing, like some data governance, the kind of ability to touch all of kind of your tables and run some sort of transactional capabilities on top of them, yet while maintaining very fast read speeds, right? It was all about OLAP at the time. And so you're trying to reintroduce that to kind of a V2. I think Lakehouse more of like a V2 version of the data lake, or fixing all the initial problems that happened when we had from the Hadoop eras and things like that. And so technologies like Trino and Iceberg and are starting to build, storage formats and all these things. Oh, I am getting a can't hear you. Is anybody else not able to hear me? That is tuning in right now. Let's see. Let's see. Anybody else that's tuned in right now, can you hear me? Is it so? Okay, I got it. It's okay. I can hear you fine. Can hear you loud and clear. So Harish, I unfortunately think that might be some audio thing on your end. If you can take a look in that. Actually, he can't hear me, so I should probably reply to him via comment right now. Let me go ahead and do that real fast. Harish, seems like everyone is able to hear me on. So maybe an audio issue. Sorry, I'm doing this live, folks, but didn't have anybody else on the back end to send that message via the LinkedIn comments there. So if you're on YouTube, I'm talking to somebody else in the LinkedIn side. Okay, getting back to things now. So hopefully Harish gets that figured out. So lake houses, in essence, though, are kind of like V2 version of data lakes and things that we had gotten wrong before. And so, Trino, Iceberg are technologies that are pulling us into this new version of the data lake that is able to, kind of handle orphan files and do all these like really cool consolidation of the data in a way that reads are just as fast as they are in a data warehouse. And yet you're still able to take advantage of a lot of the cost savings that you get from moving into kind of like these cloud storages, and you run on top of that. So in essence, lake houses are kind of the next iteration of where we're going with data lakes. And so I'm really excited to learn about that and how Trino is a part of that, and how to basically set something like that up. So today we're going to be talking about do a couple community updates as we typically do. So then I'll do a little bit of a Trino Starburst overview for those of you who are not familiar with Trino, and then my company Starburst, to kind of give you all a bit of a concept. And then we're going to just jump right into it with Aaron. And by the way, Aaron is from Privacera. It's one of our close partners that we work with. And they have a solution that builds on top of Ranger, provides a lot of fun, cool access control, and makes it super, super simple. So, but that's not what he's going to actually be talking to us about today. It's actually going to be talking specifically more about Trino. So excited to hear that. So if you're new to the Trino community, I wanted to give you a couple of these links. And so if you are concerned about getting these links right away, don't worry. This will be on a YouTube recording here in a little bit, so you'll be able to kind of go back, rewind, and pause the video at a particular time and see these URLs. Typically, Anna is the one that's putting a page that links to this, and I actually don't have it today because she'll usually link you to all of these links for me, and she's out today sick. So, but best place to go, and this one you can just remember off the top of your head. Go to trino.io/Slack. You don't have to add the HTML thing that's in there if you don't want to. Just trino.io/Slack, and that'll take you to a page where you can sign up and join our Slack group. We are just getting close to about 8,500 with a weekly active users around. We had it actually up at 1,000 around the Trino Summit, but it went back down to around 800s. So we're in the 800s of weekly active users right now in the Trino on that group, and so it's very active. We have about 150 posts per week, and so that's people posting the initial one, and then there's the comments that come after that. So it's pretty active Slack channel, and that's definitely where we recommend you learn how to use Trino as well as contribute to Trino. And speaking about contributing to Trino, this one here to the right, if you want to contribute to the project, you can also go to trino.io/development, and that's going to give you this kind of top level page on how to get started. And if you wanted to contribute a new feature or just kind of hop into our GitHub and learn about some good first kind of pull requests or first issues to start working on if you wanting to get involved in open source. Then hopping back to the left, I don't know why I'm doing this zigzag thing today, but we're going to go with it. So Trino Community Broadcast, that's a show that I and Manfred Moser and myself do host for, as well as now Cole Bowden. I almost forgot him. He just joined us earlier this year and has been joining us for a couple of these broadcasts. So go to trino.io/broadcast, and that'll give you some of the most recent episodes. We're actually going to be having one coming up this Thursday, talking to the folks from Alluxio to learn about caching. So that's going to be pretty exciting. If you want to get involved by, maybe code's not necessarily the thing you want to contribute, you just want to talk about your experience, the blog can be found at trino.io/blog. If you want to contribute that, you reach out directly to me, and you can find me again on Slack or LinkedIn, wherever you know me from. And then you can also contribute docs. That's another kind of, low barrier to entry way to kind of start, kind of providing immediate value to a lot of people. Our docs are definitely really pretty good, but it's always, there's always these kind of niche use cases where we're, we need more fuller documentation or clear documentation. So definitely take a look at some of the docs, and especially the getting good first issues on there. If you're here right now, you are at one of the Trino virtual meetups, the one in the Americas. We also have an EMEA APAC that we're building out, and is definitely going to be something that as we go to a hybrid meetup strategy, we're going to be doing a lot of these in person, but then streaming them from the in-person ones and doing them to these respective groups. So really excited to get started on that. And then finally, there is a Trino forum, which the URL is not there. I need to fix that, but it's trinoforum.org. And if you go to trinoforum.org, that is one of the other areas that we want to try to take a lot of the conversations happening in Slack and make them publicly available on the forum so that you can search it through Google and things like that. All right, so that was a lot. For coming today, if you sign up in at this URL, and again, I apologize. Let me see if I can actually take this. Oops. Let me take that URL. And I'm just going to paste that into the chat because this is the one that's not easy to remember. I'm going to paste that in the chat here in case anybody wants to get a shirt. So yeah, go ahead and get a shirt there. For being here today, if you have not gotten a shirt before, fill out this form, and then we will basically send you a shirt. If you're in a country where we can't send it to you, then we will send you a gift card, and we apologize for that. Okay, so let me hop real fast in. I've already eaten up a little bit of Aaron's time by debugging some sound issues. So let's go right into what is Trino and what is Starburst. So Trino is a high performance MPP SQL query engine. So that's a lot of like stuff right there. So why do we need a high performance MPP SQL query engine? Well, the big issue that Trino tends to solve is that you are able to actually address and talk to multiple different storage units. And so storage units might be something like a database, so like you have Postgres, or a NoSQL database like Mongo or Elasticsearch. You could also have what we're talking about today, the data lakehouse, or data lake type setup, where you're talking to some system like Hive, or which is kind of the data lake v1, and the data lake v2, the lakehouse stuff. We also have connectors that talk to Hootie, Delta Lake, and Iceberg. And so so I think Aaron's going to be talking to you a little bit about the Iceberg side of that today. But yeah, you're also able to connect to your data lake. You're also able to connect to other things like real-time data stores, Pinot, Druid, and ClickHouse. And so all of these different things that you're able to connect to basically enable you to run these really cool joins across these disparate systems. And you're actually running a portion of the computation in the source system based on the push downs and everything that we have enabled in each of the different connectors. But then all of the stuff that we need to continue answering the query gets pulled up into Trino, into these different distributed nodes called workers. And this is where we start getting into that SQL engine part. So you're sorry, the MPP engine part. The SQL part is more about how you're interacting with it. So the MPP aspect of it is a multiple parallel system that allows you to actually take essentially the data. First, maybe you'll split by nodes, so that kind of goes across distributed set of nodes, and then further at the node level, you're going to be doing intra-node parallelism, which is going to split the different problems into like maybe smaller hash buckets or different things depending on the exact query that you're running, and you can actually keep cutting the problem down into smaller and smaller units. That gets done across multi-threaded instances or on multi-threads on Trino, basically on the individual node. And so this makes it super fast. It's proven scalability at up to multi-petabyte scales. We've seen at places like Salesforce, and then the biggest thing is that it's incredibly fast in terms of the latency and turnaround, making it very initially acceptable as like an interactive query engine. More and more people now, though, are starting to adopt Trino for its speed as an ETL engine, more so than just an interactive engine. And so that's kind of one of these newer elements that we've even added with a fault tolerance execution mode using various exchanges in between all of the different tasks. So that gets into a lot more of the weeds, but most importantly, Trino is able to do federated queries. It's able to do this really fast and at scale. It's community driven. It's it's run a lot of the features that are being actively worked on are done by contributors like Netflix, was it Salesforce? I just said their name, Amazon, Starburst, and a whole truckload more of folks that are contributing different features each day. So really exciting times, and it's super scalable, and people just bringing in their own use cases and solving those use cases and bringing it to the general audience, right? Separation of compute and store. So this is kind of the typical thing that we did with big data, making sure that our compute is basically handling all of this data, and Trino kind of treats all of these things as like generically talking to the SPI, and it can go over multiple different units of storage now, depending on what data storage you're specifically talking to, which connector you're using, and then deploy anywhere. And this is going to be some stuff that Aaron's going to be getting into. Is we can deploy via Kubernetes, you can deploy via cloud, and then you can deploy on-prem. So Starburst. So the company I work for, I'm a developer advocate at a company called Starburst, and we are essentially built on top of the Trino distribution, and we build two various distributions on top of that. We have a enterprise version that is essentially kind of a modified and extended version of the open source. that you can still deploy locally. You do it the similar kind of methods, the way that you deploy open source. You can also deploy the enterprise version in the same way. It just has a lot more connectors, a lot more performance, and has, also buys our support along with that. Then we have the more recently released Starburst Galaxy, which is the SaaS product. And so the SaaS product is basically, the button push in the cloud, and essentially everything gets pulled up. We manage the scaling for you. We manage a lot of the various deployment aspects for you, and you no longer, with SEP, you're still managing the, once you push the button and get everything inflated, you still have to manage making sure it stays up. Versus Galaxy is all managed by Starburst. So that is, and on top of that, we have a lot of these cool integrations, like with companies like Privacera, like where Aaron works, where we have extra security features, and we also integrate as well with a lot of other SaaS providers. DBT, well, sorry, I take it back. DBT Labs is still in progress, but that is one coming around the bend. And then and so basically, I think you get the gist. Starburst is enterprise version of Trino, and it's definitely something to look into, especially Galaxy. You can try out for free, and it's a pretty straightforward and easy way to just play with Trino without having to get too much in the weeds of deploying it. So without further ado, I don't want to take up too much more time. One last thing I did want to say before I bring Aaron on is we did just have a Trino Summit. Let me real quickly do talk about that. So if you go to Trino.io, one of the you'll see a couple of these blogs that have recently come out, and these are basically just recap summaries of all of the different talks that we had going through. And so if you go to the first top level Trino Summit 2022 recap, in fact, I'll post that one in here. We're going to, oops, I'm missing this here. We're going to post eventually all of these. Let me paste that in there, and I'm sending that via the YouTube link. We're going to eventually paste all of these, and you'll be able to go down through here, read about the overview of what happened at the Trino Summit. And in each of these, you can either click on the YouTube link, or you can click on the read more link, and that'll actually take you to all the individual blogs. And so we're still in the process of pushing out all of them, but it was an incredibly fantastic and successful summit. The talks were like freaking blew me away. It was definitely one of the best events that I've set up so far yet, and helped set up so far with the help of course, all of the marketing and events team at Starburst, and then getting help from Manfred and my other fellow DevRel advocates there. So definitely check those out. Really exciting stuff there, and has a lot of great advice for running a lot of your Trino stuff at scale. So without further ado, let's get right into the meat and potatoes. Bring up Aaron here, and we'll switch over to you, sir. How to build a lake house simply. So how do you build a lake house simply?
Yeah, totally. Let's get into it. So I'm broadcasting from the inside of this lake house, as you can see.
Nice. With a piano in the background.
The piano. I play that all the time when I'm not at the orchestra or using Trino. Yeah. So just a little bit about this slide, right? So my name's Aaron Colcard, Senior Director for the Center of Excellence at privacera. So Brian had mentioned a little bit of what privacera is. So like Trino, as an open source project, has its umbrella of Starburst as a commercial vendor supporting it. Apache Ranger, which was designed as a security solution for the same ecosystem, has its umbrella company at privacera, where we have enhanced and expanded that product so that we can bring security and data governance to these types of products at scale. No greater lake than Lake Superior, which is where we're going to build our lake, lake house, and we're going to take the word simply very seriously, because as we go into this, I'm going to show you the patterns that I personally had to go through to build a lake house with Trino, and how I dug into each of these features to understand how I could actually make something extremely simple and bring it to production and host at my current rate. I think I have around 25 or 30 billion records. which is only a couple months of actual data, but the amount of scale that I'm able to get is just phenomenal when you think that I'm literally building a lake house. I'm not renting it, I'm building it. So I'm going to live in it just like I virtually am right here. So let's give a little context onto the background. So privacera, this is kind of like the ecosystem as we see it, and our product really is down there around the data privacy and access governance. But when we kind of go up the layers, right, we have these other layers such as data catalogs, data transformation, data ingestion, cloud warehouses, and then now we have cloud data lakehouse. And they can all help us begin to fulfill the data science and the BI use cases at a scale that we've never been able to do before, almost unimaginable. And some of the patterns that we're going to dig into are literally going to tackle some of these data ingestion patterns simply and show us exactly how we can actually build something just like this. Just even with just the open source project of Trino itself, which is a fantastic project. It's just amazing. So a couple months ago, I set out a couple project goals, and it was center of excellence. So let's go into what that is. Where I work with our customers to come up with some best practices and patterns so that they can really unlock those high levels of compliance and privacy that our customers are looking for using their tool. But we wanted to build an analytics program underneath it so that we could be data driven, so we could actually look out and say, what are customers doing? How do we understand the product, right? How do we understand our product usage so that we can help our customers achieve more and then subsequently improve our own product? Are we understanding exactly what is being done? So we want to make sure that we're bringing together some of these best practices, but more importantly, right? What has been the common thing for us to do in the last couple of years with our programs is we eat our own dog food. What we're building, what we're creating, we're also using it to solve our own problems. And I wanted to make sure that we're building a data stack just like our customers are doing. How are they bringing things together and how are they integrating? I also wanted to understand exactly how to do things with an open standards approach. So what that meant to me was look to open source first, see what I can do. But when I think about what my first sentence simply, I don't have a lot of resources. There's been me and maybe one other person helping me. So all I had to achieve with a very small team being very clever. So we had to be agile. We had to think about what we're actually going to what we're actually going to do. If it's going to take us 5 hours or 5 days, what's that choice? How do we go through that? That's really pushing simply. So before this, I just want to give this disclaimer. At privacera, we love all of the different stacks, all the modern data stacks. They have all the strengths and weaknesses. They balance out differently. These choices of how we built this was only based on the journey and the amount of effort. Given the different use cases, we might have gone a different way. But nonetheless, this still allowed me to create something what I thought was pretty amazing, something that, as I said, is hitting an exceptional amount of volume at an exceptional amount of speed. So let's talk about what a lakehouse is. All right. Lakehouse is new. Didn't exist a couple years ago. So it is an open standard about how we bring, and it's designed literally to bring together what was the strengths of the data lake together, what were the strengths of the warehouse, and how do you bring those together so that you can have machine learning and BI coexisting in the same ecosystem, being flexible, cost efficient, having separation of compute and storage so that what you maintain over here is different than how you're actually storing it. A lot of robustness inside that type of ecosystem. There's a concept of like, how do we get flexibility? How do we, rather than always like in the warehouse, we always had to transform every bit of data to fit into a structure. In the lakehouse, we don't. We can leave some of that unstructured, and we can leverage approaches to virtualize it or materialize it on demand. It also fixed a lot of, and it's also fixed a lot of problems with how data lakes initially got deployed. When data lakes first got deployed, there's a lot of excitement. We started putting data onto the data lake, and then subsequently couldn't sometimes find that data. And they gave it the nickname of the data swamp because we had the data out there, and it might have been transformed, it might not have been transformed. We didn't have the metadata. We didn't really have any governance over it. So Lakehouse, the creation of this allows us to actually start solving those issues. Like, how do we make sure our data is consistent, even understand how some of our structures. And, I put in here a little call out to data mesh because there's a lot of similarity to Lakehouse to data mesh, which is also a really new concept. And I would say like the key difference is Lakehouse can be open, sometimes up to a certain layer, whereas data mesh is usually trying to chase the openness to every single layer. And that's more of a call out that we're going to see different vendors in the space talking about Lakehouse, and just look to see where their openness stops and how they approach the openness equation. One of the things that I liked with using Trino, as well as what you can see on the side there, I have the logo for Iceberg. Iceberg is wonderfully performant, and I'll share some of that experiences there. One thing that I enjoyed was we're truly open from top to bottom here, and as well as being extremely simple. So let's talk about that. Let's talk about this open architecture. Let's talk about like why even to use Iceberg. As I said, we love all of our vendors. So whether or not it's us thinking about Trino and Starburst, if we wanted to, by using Iceberg underneath here and storing it, we have options. We have options with other vendors to figure out how to unlock that data across this ecosystem. So being truly open, truly a lake house, not having that vendor lock-in, and then just making your choices based on what makes best sense, right? In my cases, my choices were like, how do I embrace how do I embrace openness, right? How do I do the choices first, right? That gets me the outcomes that I want. And then if it fits my use case, then I'll figure out how to expand it. So let's get into my recipe. So I have a recipe for how I put together this. Okay, we have Trino, we have Iceberg, which we've mentioned. We have another open source project called Apache Superset, which will allow us to create dashboards, BI, reports, self-service democratized analytics. We'll use Dagster to coordinate our orchestration. We won't show that in action today, but maybe you might find me showing that in another spot. That allows me to bring together the entire orchestration of the system. Other components, shopping list, right? So the shopping list reflects the things that aren't open source that I might have to pay for, still pretty affordable. Amazon's EKS, Elastic Kubernetes Services. So we're going to talk about how we're going to put Trino onto Kubernetes and deploy it. S3, that's going to be our storage source where we're going to put the data or put the Iceberg structures. EC2, obviously, that's what EKS is using to run. We'll talk a little bit about what are my experiences with the nodes. So I played around a lot with the nodes to see what really worked for me. And AWS Glue, which is a pretty popular pattern for a Hive metastore. And the Hive metastore allows us to, as I showed you in the last slide, allows us to create the structure in one spot and then truly share it. That data mesh concept being able to have multiple different systems working together to support. I did put as directions, be careful in mixing this, because it may explode to billions and billions of records. And you may be pleasantly surprised when it starts getting up to that scale, because you may not notice any degradation of speed, which is actually really fantastic. So let's talk about my first simple pattern. So we're going to start logically here before we get physically. So our data lake plus our data warehouse equals the lakehouse. So as I was putting this together, one of the patterns that I looked for was, how do I put this data inside of our system with as little ETL as possible, and to try to use as much fat and allow the data to transform as fast as possible. So I think I'm 25 billion records, definitely. That used to take a very long time to do millions of records. And my transformations do take under 5 minutes. And they actually start, all my auditing data will start in a JSON format, completely unstructured. And we will use a feature to actually tap that and move that across inside Trino and allow Trino to recompile that into Iceberg structures. And we have description data such as, who might our customers who are using our product, because that's what we're trying to do. We're trying to optimize so that we can understand their partner, what their usage is, so that we can improve our product. So we store that information structured, and we'll bring that together so that we are obeying, as you can notice on the right side, almost traditional data warehouse terminology: fact tables, dimension tables, aggregate tables. All these patterns will help us actually unlock it in Superset through using Trino. So let's jump ahead a little bit. So let's do our base. Let's talk about some of our building our dimensions and facts. How do I actually tap that unstructured data that's sitting almost exclusively in JSON without changing it a lot? So I'm gonna recall the old days when I had this problem. In the old days, I had to go get Spark ETL to read all this JSON, write it into a data frame, and then rewrite it out to S3 structured, usually something like Parquet or another intermediate step. Well, I'm not going to do that this time. When I'll talk a little bit about like how fast this project can work sometimes. Trino changes extremely fast. It's almost like the end of Ferris Bueller's Day Off, where he says, if you look around, you just might miss something. That's how fast Trino works on their updates. So when I started the project, there was no such thing as partition projection. I had a problem. I'm like, okay, how am I going to go get all this data that's being written across S3 with multiple folders, multiple layers, and bring that data in, because it's also all JSON? Well, luckily, a feature that was present in AWS Athena was ported over into Trino. And that feature allows us to actually build a table that has a map of what the JSON will look like, and also a template of how that S3 structure also is built in. And now we don't even have to have another system to build ETL. I mean, I was trying to build, I was building the Spark system to build this, and then I'm like, okay, I don't have to build it anymore, because that changed my equation of 5 days to 5 hours. Literally eliminated it. All I have to do now to find that table and do a select into create table as. Done. That data will then automatically, Trino will spring into action, move that data across, and recreate it. Some practical experience for those who are familiar with how Athena does their storage template. Pay very close attention to the Trino documentation. It is accurate. Just read it, and it will guide you to the right way of building that table. I would show an example, but I figured I'd be getting too much into the weeds. The other aspect, how did I go get those dimensions? How did I get those data aspects? Well, the beautiful thing about Trino is the federation capability, the ability for us just to connect to that data source in place and then to connect it. So that's what we did. We created a connection to the database, and then we pulled that data in through the federated compute through federated queries and did the transformation in place. All this while also providing ACID transaction. So recalling patterns that may only be made a year in the past, it used to be almost impossible just to use SQL on these types of systems because you had to understand the partitioning itself, how the table was physically laid out, how the parquet was actually laid out. But now with Apache Iceberg, it's building it into Parquet. It's also giving us the optimization and vacuum commands to re-optimize and keep it in action. It's also giving us the snapshot capability, but it's more importantly giving us the ACID transaction capabilities. And even cooler, as I said, if you look around and you wait just a little bit, you might get a new feature extremely fast. In those couple months, merge got added as a SQL syntax, which allowed us to actually write dimension or SCD, slowly changing dimension type 2 structures extremely simply. Just one single SQL syntax. Now, the next phase of how I made this also extremely simple was I began to realize I don't actually have to write a lot of ETL. That actually made it fun for me writing Python-based orchestrations inside Dagster, which were very similar to how we write them in Airflow, because all of a sudden I was beginning to write SQL again because it was faster and easier because the syntax was easier. So I started when we wanted to build aggregate tables. Now, why did we build aggregate tables? Well, aggregate tables allow us to skip going back through every single one of those records and to focus in on the metrics. So at this point, we can start defining metrics to what we want to see inside the end reports. And we'll build the aggregate tables to help accelerate those metrics. Very typical warehouse pattern, building aggregate tables. Now, I'm going to note, configured exchange manager. What does that mean? So another cool feature that showed up in the last couple of months was Trino added the exchange manager or robust query handling. So now we could run queries that were handling an exceptional amount of data. And if they failed, we could configure the amount of robustness that we wanted in the query. We could say we didn't want anything at all, just fail if you find a problem. That used to be the default behavior of Trino. We could now say if the query fails, retry the query. Or we could also tell it when you break that query apart into tasks, just that task that failed, rerun that. So configuring the task manager, we configured the task manager, configured it for the task, so that as we run it, if it fails at the task level, we get it automatically rerunning and recovering without suffering a lot of slowdowns. That's really important when we're using Kubernetes, because the Kubernetes is going to be handling the pod management. Usually, almost reliably, the system was going to be very high amount of uptime, but you never know what could happen, right? You can hit any type of exception. There could be scheduling problems. If I'm not going to get into it, but we started using spot instances. So, when the spot instances go away, we wanted to be able to recover extremely reliably without being interrupted. So with the aggregate tables, this was also another simple pattern. Okay, let's avoid ETL. Let's not build a big orchestration process. So aggregate tables in the past, by building them, you'd materialize them and you'd rewrite the data into the structure. And if you had any problems, such as the data was late or you had to update some of the data, then you would inevitably have to go back, delete that data, ask the ETL system or orchestration system to start at a certain day and backfill or rerun that process. Well, let's avoid that. Let's use some features inside Trino to avoid that. So what we do is we actually take our data structures, we just create a simple view for the daily level. And this is the one that actually has the joins to the dimensions. So you now have your fact tables that are containing activity joined to your dimensions with a very simple view. Now we'll build our monthly, quarterly, annual views on top of it, but we'll make those materialized views, meaning that it'll be up to Trino when we run. We'll now add the refresh materialized view to the end of our orchestration jobs so that after we ask the system to convert the JSON into an Iceberg table and to convert the dimension tables into a slowly changing dimension, now we'll just we'll just do the refresh of the materialized views, and it will rebuild the aggregate structures. And then we'll use Superset to go against the aggregate structure because we'll get metrics. I'll just tell you, this was, once this started working, I just had so much fun with it because I'm like, I don't have to build complicated ETL processes anymore if I have data that might be late, or if data I found was wrong and I had to redo it. All I had to do was just go back and change joins or change the syntax of the SQL and rerun the refresh jobs. Literally simple. Okay, before I move off of this topic and go into the physical, I mentioned Dagster. Dagster allows us also to write a lot of structures that Airflow can also use, and we usually write those orchestrations in Python. So you may think, okay, using Trino, boy, I've learned modern data systems, I know all this great stuff. I don't want to go back to SQL because there's all these problems with SQL or the syntax. Okay, we got you. There is a Python client, and that is actually literally how we've written all of our orchestrations, is with the Python client. So it looks exactly as how you would write an orchestration job in any other system. Just the exact same. Very little difference. You're going to create the classes, you'll create the structures, and then you'll send it through this orchestration system and it can build it. So let's talk a little bit on the physical side. So on the physical side, we're using Kubernetes. Elastic Kubernetes, EKS for AWS. Every one of our cloud vendors, Azure, GK, Google, AWS, they have some form of Kubernetes that you can deploy this to. This is how we build our data, our lakehouse, so we can live into it. There's two main Helm charts. So the Helm charts are our key to making this simple. So the complicated way is to learn how to use kubectl and to write all the commands. The simple way, use the Helm charts. The Helm charts are great because they are getting updated by the community, and they're getting a lot of shared knowledge of how to run Trino. Now, I had mentioned this to Brian, and so I'm going to mention that the Trino Helm charts so far have been rarely updated, but they are going to be getting a maintainer and those should come up and start being updated a lot more frequently, extremely soon. And that's going to help us out a lot. If you're looking right now, if you're looking for some of the fastest updates on Helm, you'll usually find them in the Valerino Helm charts. So there's two. He updates those almost so fast, almost weekly, daily, that you'll find some new change in there. You can choose both or either. What I've seen is that a lot of the project tardigrade or the ETL robustness has gone into the normal Trino Helm charts. I really haven't seen those in the Valerino yet. But then there's also some great stuff in there. Once they get that maintainer. So I'd advise, like, start with the Trino Helm charts, see how well it goes. You should be in good shape. You'll be able to very quickly build out Helm charts that will allow you to templatize your production, which is what I've done. So I've templatized our production, so I have a Helm chart that I can use to deploy against my development, and I use that same Helm chart to deploy against the production. Just some small changes in between. Those are handled by environment variables. The next element of keeping things simple is terraform your Kubernetes cluster. Not too hard. You'll standardize some of your security for your Kubernetes, for your EKS, and then you configure your node groups and your affinity. Your affinity is, by the way, I would recommend that you actually create a node group for your coordinator and another separate one for your actual worker nodes. That way you can actually manage them separately. Typically, your nodes are going to be about the same or have the same amount of resources, but what you'll find is the ability for you to customize how, like, for example, spot instances could be customized on your worker node group to allow you to use spot instances there, and then to use a constantly available node for your coordinator. So that every time, because it can, if you put everything in the one node group, sometimes you can find that the Kubernetes scheduler isn't wanting to schedule exactly the way you want it to, and you don't have a coordinator. So make sure there's a coordinator node group in Affinity. More on the physical side of implementation, keeping it simple. I just wanted to share this experience. I put the equation at the bottom. There are a lot of articles out there on resource management for Trino. There's a really great video on the Trino YouTube channel that you can find. I'm going to give you that entire presentation right now. Interesting. We'll just jump ahead. I'll give you the entire I'll give you the entire experience of that. Pretty much, if you put out a node that has 128 gigabytes per node, put 70 gigs for your max memory per node configuration, and 30 gigabytes for your headroom, and then save 28 for the swap OS. There's the actual equation is much more complicated, but that'll create a pretty robust and pretty performant node. What I have learned, because I'm sure when you come into the project and you're trying to learn it for the first time, you have questions like, what is the best type of node? If you really need it to be extremely performant and finish with the fastest queries, go compute. If you're okay trading off for a little bit cheaper and not having it go as fast, use the memory nodes, the R types. You'll find that the difference is so very close, but it can be, it depends upon how much you're planning for your concurrency and how much you're planning for how fast you want your actual queries to finish. But that's just my general observation, was the compute was faster, but memory nodes were cheaper. I myself have decided to go for memory nodes because it's just made the actual core combination with the node groups and the spot instances a lot better. Tales of a Journey. So I put these in before I saw that Brian had all those great links at the beginning. The blog is fantastic. The Slack, join it if you're going to use Trino. There's always new information, new announcements. Everybody's really helpful down there. There's amazing amount of video resources on Trino. If you get bored with looking for Trino resources, you can use the word Presto. You'll find a lot of compatible advice there too, using what the engine formerly known as Presto. When I began the project, there was like a long list of product features that I was like, I really wish I had this because this would really save my job, make my job a lot easier to finish this. And the thing is I think that there's probably a release of Trino almost every 2 weeks. And so I literally can just say, like, if you need a feature and you're waiting for it, just wait 5 minutes. And if you're really antsy, go check the GitHub to see whether or not someone's already filed it or is about to commit it or it's about to roll in. It's amazing how fast it is. I think right now we're at release 403. I was amusing myself that right now I still can't find the 404 release. With that, I think we're just about wrapped up here. I'd love to take any questions if you have any.
That was awesome, Aaron. Yeah. We're still working on the 404 one. Don't know when it will come.
Yeah, I'm expecting you guys to just go to 405, but
yeah. It hasn't been thrown off the table yet. So, anyways, I do want to open it up. That was a great presentation, by the way, Aaron. Really liked that. I mean, a lot of times you'll get kind of high level descriptions about like kind of the ways you'll set up these views in the all of the orchestration. And so thanks for going into the details there. I think it's interesting. Your talk would have been very well, like fitting in super well at the summit, because you talked about a lot of, maybe 3 or 4 talks talked about, basically the current the status of what they were like when they were in Hive, and then they migrated over to Iceberg, their orchestration and moving everything into using some sort of Kubernetes setup. And the final one was we did have Zillow talking about their using spots, Trino on spots. And so I was just like, wow, like you covered like a good chunk of the material that we were talking about at Trino Summit. So I'm glad that we at least were able to get you on and just after and have you kind of essentially recap the summit for us.
Yeah, pleasure.
Yeah. So one thing I wanted to say about, when you're talking about looking back on the GitHub pull requests and things like that. So me, Manfred, and Cole right now, if you've ever contributed to Trino and you maybe got a PR that was a little stale, we've been going through the backlogs right now and basically, checking to see if people are still actively like working on something, kind of apologizing if their stuff fell through the cracks. And we're now actively like making sure that things don't fall in the crack moving forward. We've picked up a lot of the backlog of basically abandoned tasks, either on one side or the other, like maintainer didn't get back to it and everybody just forgot about it, or the people themselves didn't reply to the maintainer, and then we were just kind of closing things. So what you see now, we got it from like 600 something in the PRs. We're now under 300. And so, and we didn't want to just go the stale bot route. We wanted to actually have humans go through and make sure. And we've actually picked up a lot of cool features along the way of doing this backlog slush through. So, so you may see us responding, but I wanted to say all of that to say that there's not a lot to look through now when you're trying to figure out, well, what are people actively working on? And that's one of the big points of why we did this, is like, we wanted to make it very simple. Like and ideally we want to get it down to where it's close to around 200 PRs. Now, granted, if it naturally we are over, actively over 200 PRs at a time, that's fine. But we want it to be as thin as possible so that you actually see a good representation of the work that's actually being done today to run through the PR. So if you saw the PRs going down, that's why. If you had a PR in there and we reached out and eventually closed your PR, you can feel free to open it back up, by the way. It's just, we're just trying to basically have a solid representation of that. So that being said, we are escalating things. Like, we're making sure the developer experience, whether you're using or developing for Trino, we want to make that experience like super good. So reach out to me if you have had a strange experience like that, including the Helm chart experience that you mentioned, Aaron. Like, that's stuff that we hear, we do hear, and we see you, and we're trying to do a better job at communicating when we're working on those things. And so now I'll say it again, we are actively trying to get a maintainer in to see about, somebody kind of more owning and somebody who has a better understanding of Kubernetes. Let's just say that. What we don't want to do is just haphazardly merge things into an official Helm repo, and then, it messes up the setup when people start to upgrade. So that's why we're being very calm and calculated, and people are thinking, well, have you abandoned the Helm chart? And that's not the case. We just want to make sure that we're not introducing any bugs and make sure that we're very thoughtful around it. So, in the time being, we will eventually squash that, but it'll just give us some months. And I think that'll get squashed here shortly. I haven't seen any questions come through, Aaron. I do think that gets us to just maybe we'll wait another minute before we totally hop off. But we had a decent amount of people watching and listening. I guess your presentation was very clear.
Yeah, awesome.
Cool. So is there any upgrades that you're trying to get going on your dog food cluster right now? Or are you trying to integrate anything extra to this?
No. Well, right now I think I'm just refining around the Kubernetes environment variables. Something that's just very straight and direct on that one. I think the advice that I was trying to clue in around using Terraform for your Kubernetes was, I found that it makes configuration of IAM roles in Trino much simpler if you actually understood how you actually were implementing your security on your node groups through Terraform.
Yeah.
Because otherwise, EKS by default will create differing roles and users on those groups that then you have to kind of like fuss around and figure out later.
It might be something to do some tutorials around later too, because I know that's especially something that like anybody, it's one thing to get Trino up and running, but then adding in the extra pieces, which I thought EKS could handle, EKS CTL handles. You can manage some of that in there, but I know it's not a full-fledged. It's not a full-fledged tool. I don't know if it's like more of a toy than anything. I use it as a toy because I like to get people up and running on EKS using that thing. But yeah, Terraform is much more production ready, I would say. And it also works on other things outside of AWS if that hits your fancy. So cool. We did get a question. Where can we find out more about the partition projection in Trino? So that's more to me. I know this. Do you have an answer for that, Aaron?
I will tell you that you will find it in the documentation. All you have to do is search for it. What I found, this is just my practical advice. So what I found was it's documented. At first, when it got documented, I was like, "What the heck?" Because it just you just kind of, I couldn't wrap my head around it. Like where the projection was. Just follow exactly how they documented it. It's very straight and direct, So try it out that way. If not, I'm sure reach out onto the Slack channel, and I can always post even an example, because that's where I was looking for it originally.
Nice. All right, thanks, Greg, for that question. Yeah, thanks. With that, we're at the top of the hour. So thanks again for joining us, Aaron. And here, I'll put up my little thank you slide. Do give us a star at github.com/TrinoDB/Trino, and follow us on Twitter at TrinoDB. If Twitter's still around next week, who knows? So great. Thanks again. And I will see you all next month.